Welcome to the home of science. Okay, so we have a question there. So let's go straight to answering that question. It came from 2019 internal. Yeah, some of my followers requested that I answer a question on the polymers. So we have a question there on nylon and toluene being polymers. Okay, so let's go straight to the question. Remember, before we even start solving, remember to invite more of your friends to the Home of Science paper 2. Okay, you can also follow me on my YouTube channel, that is Katenda 94277 without leaving a space there. Okay, so the question reads there: nylon and toluene are polymers. Okay, nylon and toluene are polymers. A. What is meant by the term polymer? So what is meant by the term polymer? Okay, so a polymer is a giant molecule which is formed from the combination of two or more monomers, which are small molecules. Okay, so we are saying a polymer is a giant molecule formed from the combination of two or more small molecules known as monomers. Okay, so I'll write the answer for you here for those of you that would love to see answers. Okay, so we are saying polymer, which is a polymer is a giant molecule formed by the combination or joining of small units known as monomers. Okay, so that is the definition of a polymer. Okay, we move on to B. Okay, B reads: apart from being polymers, give one similarity between the two. Okay, apart from being polymers, that is nylon and toluene. Apart from being polymers, we give one similarity between the two. Okay, so the similarity is that they are both synthetic polymers, meaning they are both man-made polymers, or they are both artificial polymers, which is just one thing that we are talking about here. So both nylon and toluene are synthetic polymers. So B, we are saying they are both synthetic polymers. Synthetic, same as man-made or artificial. Okay, the other one, okay, since there they just asked for one similarity, but just for reference, the other similarity is that they are both made. Okay, one of their monomers is dicarboxylic acid. So nylon as the monomer, which is dicarboxylic acid, also toluene as that same monomer, which is dicarboxylic acid. So that is one similarity. Another similarity. Okay, so we have one similarity being given there, which they asked for, which we have written there. So we move on to the next question, which is the C now. So it is the C1 and C2. Okay, which of the two polymers is a polyester? Which of the two polymers is a polyester? So we have the two polymers, which is terylene and nylon. So the polyester there, it is terylene. Okay. We'll show, since there is a next question there, we'll show why terylene is a polyester. Okay. So we are saying terylene. Terylene. This is R, sorry. And L-N-E. Okay. So terylene. Okay, so terylene is the polyester there, where they said which of the two polymers is a polyester. We have said terylene. Okay. Okay, we move on. Then C2, they are saying hence draw the structure of the polymer showing two repeating units in cycle N ester link on the chain. Okay, so now we draw sorry, excuse me, we draw the structure of the same polymer we have named in C1, then showing two repeating units. Then we also in cycle N link on the chain. Okay, here we are just asked to draw, but I would love to show you how terylene is formed. So I'll go through the steps which are involved there in order to show you how terylene is formed. Okay, let's go straight to it. So it is C2. Okay, so like I was saying, the monomers for terylene, we have di-O, which is two alcohols there. So we have HO, which is OH. We also have this side, which is di-O. Then the other monomer, it is dicarboxylic acid or dioic. Okay, so these two boxes, we can differentiate them if we want. We can differentiate them by painting one, or even if we don't differentiate them, it is fine. So this is dicarboxylic acid. So for carboxylic acid, we know that they have the functional group, which is COOH, which is the one here. So when they say dicarboxylic acid, meaning we have these two functional group. This box is not just a box, it is the carbon chain. Even the box here, it is the carbon chain of an alcohol. Now that we have two OH here, OH, no wonder we are calling it di-O. So it's an alcohol containing two hydroxyl group. This one is also a carboxylic acid containing two carboxyl group or carboxylic group. Okay, let's move on. So when these two monomers condense to produce a small molecule, which is water and terylene, we do it like this. So I have this one here, we'll say HO, a box, a painted one, OH, it is this one, and then plus this one. If you want, you can just be leaving space, or you can be putting a plus here. You add this one, so we have this. And then after this, we add this one again. So let's just add about 2 from this one, 2 from this one. Then it will be fine. The next is this. So dialcohol, dicarboxylic acid, dialcohol, then it is dicarboxylic acid again. Okay. So dicarboxylic acid. Okay, so here, like I said earlier, the small molecules of water there, since this polymer is formed by condensation and polymerization, there will be a small molecule of water that will be produced there. So meaning the diol here will be losing H, and then the dicarboxylic acid will be losing OH. So that H lost from diol and the OH lost from dicarboxylic acid will form water molecules. So now this side we assume there is also dicarboxylic this side. So meaning diol loses H, even this side H. Then dicarboxylic acid, we are saying it is losing OH. So it is this and that will form H2O. Okay. Even this side loses OH, diol just H. Okay. This side diol loses H, and then also dicarboxylic acid loses OH. So meaning even this side after this we assume there is diol. So meaning dicarboxylic acid is losing H or OH there. Okay. So that's what happens there. Then we just write what remains after the elimination of water molecules pair there. Okay. So we have O. What has remained there? Oxygen dash, a painted box there dash. So which is the bond oxygen. Then we have eliminated that water molecule there, so bonded to carbon there, a double bond to oxygen, bonded to carbon chain, and then carbon chain bonded to carbon, and then carbon to double bond to oxygen. Then carbon bonded to oxygen, which is there, a bond. Then a painted box, which is a carbon chain of alcohols there. Then bonded to oxygen. We keep on going. From oxygen there, we have eliminated water molecule there, so bonded now to carbon. Then double bond, bonded to a carbon chain for carboxylic acid, then bonded to oxygen again there. Okay, so and then a last bond there. So even this side, you can put a last bond there. Okay, so now they said we were asked to draw the structure of a polymer showing two repeating units, and then we were also asked to encircle any Easter link on the chain. So repeating units, it's a pattern. It's more like a pattern where you are starting from, you end somewhere, and then you start from the same and end somewhere. So the repeating unit here, you are starting with this oxygen. It goes and ends here. And ends here. So from there, we have this repeating unit. We also have this repeating unit, meaning what is here and what is there, they are just the same. Okay. Now, the other thing they said, we encircle any Easter link. So let's circle any Easter link. So the Easter link, it's here. So this is what we call Easter link. So this Easter link, it is the reason why toluene is known as the polyester. So which was the previous question which was asked, where they said which of the two polymers, that is nylon and toluene, is a polyester. So that is the reason why toluene is a polyester. So what we have here, it is the structure of toluene. Okay, thank you so much for your time. Bye bye.